So welcome back, returning after a long time. The main thing was that cyclone Amphan, as you know, hit my place in Bengal, so I could not upload it, and I am obviously recording this a lot before 1st June. Okay. So I cannot upload this video that time. That's why I was away for a long time. So let's begin. So today we start with nothing but light, a new part in our life, light. So first let me tell you. So let's say this is light. I'm adopting a white color, blackboard white color, that kind of thing. Okay. So what is light? Now light, if you want to study light, it has to be broken down into like three main parts. First one is the reflection. Next one is the refraction. Third one is the diffraction. Okay. And now reflection you have already done in class 9. Remember reflection, there was like 1 or 2 chapters. I don't remember, 1 or 2 chapters. Refraction we'll do in class 10. Our first this chapter is only reflection or refraction of light. Refraction of light, and diffraction is the last chapter, that is the spectrum. Not going into details into the and what is diffraction. It's a phenomena of light. Okay, now see, this is also in class 10, last thing. Okay, refraction of light, lenses is the second chapter, I guess. So that is the application. So let's begin with the refraction. Now what is refraction? Why is refraction? Now I'm going to explain refraction with a very easy example. See, I have decided from now on every concept of physics, not every, means most concept of physics I will explain through an analogy. Okay. Now, what is refraction? Let me explain you. If there is like this, two surfaces are there. Okay. Let's say this is surface 1, not surfaces, mediums. Let's say two mediums. So let's say this is medium 1 and this is medium 2. So whenever light travels from one medium to another, let me go to a different color, it would be better, I guess. So light with yellow. When light travels when light travels from one medium to another, what light does is that it bends. Means it could have gone straight like this. Okay. Let me draw it with straight line like this. It could have gone like this, but now it can either go like this, either go like this. It actually bends in many cases. Sometimes this bending is like 180-degree bending. Okay, so not 180-degree bending, yes, 180-degree bending. For example, what you can do is that you take this is an experiment for you or everybody out there. Let's say you take a glass like this. Okay, you take a glass, behind the glass put a piece of paper. Okay, behind the glass put a piece of paper. On that piece, this is a see-through glass. Okay, on that piece of paper, let's say you put an arrow like this. Okay, put an arrow like this. Now when you fill it with water, okay, fill the glass with water, this, let's say this arrow, okay, this arrow will actually change direction. Sorry, will actually change direction. It will be in this direction, the opposite direction. It will, you can see this experiment. This is actually refraction in real life, if you want to say. The reason we'll tell you later. I'll tell you later. Sure, I'll tell you. But first understand, why does refraction occur? Now if you go to any simple book, it will tell you what refraction occurs due to change of speed of light in different mediums. Okay, Now you'll say, okay, I understand. Light, the speed of light changes in different mediums. So what? Why does it bend? Couldn't it go straight? That's a curious question. So let's try to visualize this through a simple experiment. Then I will tell you the analogy to the light. Let's say I have a ocean here. Not ocean, a pond, anything. Now you have, let's say, a ruler. You know what's a ruler? Maybe draw this. A ruler is nothing but that scale you have at school, okay? Now you throw with some velocity v, let's say this thing, at the water, at some angle obviously, like when it is going to fall, it will fall like this, okay? So when it falls, let's say this part, once again let me try to redraw this part before touching the water. Now let's say, obviously, like if you see, let me insert a page here, insert a page, yes. So okay, now obviously if this is one surface, there will be, like, if it is a let me draw some molecules here, okay? Molecules. Let's say the upper part is a rarer thing and this is a dense thing, okay? So obviously that will have very less molecules, so I'm not drawing that. So if you see, the light can freely travel to this, but when it travels through this, it gets many obstructions. It will get many obstructions, then it will pass. Now how will it pass? That will show, okay? So due to these obstructions, let's say initial velocity was v, it shared some velocity with this part, this atom, then with this atom, then this atom. So the final velocity vf will be less than v when it travels. So in this example we'll go again. Now let's say it has submerged a little. Change the color, okay. Now let's say it has submerged some part in the water. So if you see this part, okay, this part, let's say, has a velocity v1 and this part has a velocity v2, and I can clearly say, obviously air and water, air is obviously rarer than water, no, so v2 is obviously greater than v1. So now let's go to let's try to draw this diagram again, okay? And let's say this is thing, little bit submerged, little bit outside, okay? So now it has, remember in rotational mechanics what happened? So it has now found one axis, so this thing will go down here and this thing will go down here, okay? But this will go with velocity v, and this will get with velocity, let's say, so v2, and this will be v1. Now so since it is going a greater speed and greater time, this is going at a lower speed v1, let's say at time t, after time t, v1 will only cover this much distance, while v2 can cover, let's say, this much distance, okay? So if v1 covers this much distance and v2 covers this much distance, you can see after some time the scale will not become any more tilted, will get a little bit of horizontal. So you can see the scale is slowly moving downwards, meaning what? The angle is slowly moving towards the normal. Now you'll say, what is normal? So if this is the line, this is the water surface, this is the 90-degree angle. So initially the scale was like this at an angle of theta. Now what happens is that the scale becomes a little bit of like this. So it will be let an angle at, I'll draw it in a different way, it will be something like this. So it will be now, let's say, at an angle of theta 1. So theta 1 will be less than theta. So as you can see, it will move closer toward the normal. So we can say that when a light travels from, see the why the change of speed changes the why it is affecting the refraction. Rarer to denser medium, any substance goes, it goes to, I'm drawing normal like this, it goes closer to the normal. and when it goes to denser to rarer part, it goes away from the normal. Okay, this is the thing. Now it says this is a scale, this is not a light. What is your teaching? Actually, we never show one single photon. We are not throwing anytime. Okay, light is made out of small photons. Okay, we are not throwing a one photon, we throw a beam of light. So when we throw such light is actually, when we are when putting light on something, it is actually collection of many light rays. So in this case, our light ray is nothing but this ruler only. It resembles the ruler only. Do you understand why refraction occurs? Because on this side of the, means if this is my light rays striking a surface, on this side of my ruler the velocity is less. On this side of my ruler the velocity, if we go to rare to denser, obviously greater. So you can see there's a change of velocity, not velocity, you can say speed, because velocity will be very tough. There's a change of speed on both sides. That's why what is happening, it is bending towards the normal. Understand why does it bend? That's the fundamental thing. Without bending it can't work. So now I told you why refraction occurs and what refraction is actually. Okay, so now let me tell you the effects on velocity of light, wavelength of light, frequency of light when such a thing occurs. Okay, when such refraction occurs. Now if you can see clearly earlier, I'll again explain with a simple example. Now let's say I take the white color again. As you could see, and I explained you why this light on entering, one second, this light on entering bends from its original path. I told you the reason. Now I told you the main reason is because of the change of speed. Okay, so that means that whenever we move from a rarer to a denser medium, if we move, let's say I erase this. Okay, one second, I erase this. Rarer to the denser medium, what happens is my speed increases. Now when we move from a denser to the rarer medium, it gets more spaces, so the velocity decreases. Did I tell it right? Absolutely wrong. I was testing if you people could point out the mistake. Okay, so when we move from a rarer to denser medium, very less space, so the velocity decreases in this case. And when denser to rarer medium, it has a lot of space freely moving, so the velocity increases in this case. Now remember in sound last year, sound is a wave, and let me tell you a fun fact that light is both a wave. Light is both a wave and both a also a particle. Light is let me tell you an interesting fact. Not coming in the exam. Light is something that we call as the duality of matter. Meaning what? That there was this person called de Broglie, and let's say there was this person called the Max Planck. Okay, so what Max Planck said earlier was that light is made up of small particles. That is later we got to know the names of those particles to be photons. Okay, light is a stream of nothing but small photons. But what de Broglie later showed by mathematics, by the formula, I think E equal to mc squared, it's a very famous formula. Using this, he proved that light is also a wave. Light is also a particle. It is also a wave. How can it be possible? Light is something like that what happens is that whenever something happens, light is moving normally, let's say this is normally it's moving, but now let's say something occurs to the light, like I put a mirror here. or let's say I put a lens here. What happens is that like if we put a lens, refraction is a wave property of light. Okay, so what happens is that when light gets an obstruction, it starts behaving as a wave. It starts behaving as a wave in some cases. Like otherwise, if you have, let's say, a metal here, this is the example, it's not coming in the exam, and if you put light on this, light is represented by this wavy line. Okay, you will see that light here does not act as a wave here. I'll not draw it like this. Light does not act as a wave. It acts as nothing but small streams of particles. Small streams of very small particles. Okay, so it like here it has a particle nature. So this is a duality of light mainly. Okay, so refraction is, as I told, the wave matter. So wave formula applies. We learned this formula: V is equal to F lambda. Remember this, the F lambda or nu lambda. I remember V equal to lambda nu. Okay, many people don't have the problem of remembering the notation of nu. That's why I just wrote F lambda. Okay, so if you would see, if I put if I put F here, I can say F is nothing but V by lambda. Understand? Now if you see when we change the mediums, this velocity can increase or decrease. Okay, so now let me tell you a fact. I will explain it later. That frequency in the case of refraction is always a constant. You would say why? I will tell you later. So when velocity is increasing, to keep this frequency constant, the, like if say let the velocity is increasing in this first case, so the wavelength will automatically decrease for that value to be cancelled out. Understand? So let's take an example. Like say originally the velocity was x, now the velocity becomes 3x. So if my originally lambda was, let's say, y, now my lambda 2 has to become y by y by 3. What am I saying? Sorry, 3. Yes, 3y. Sorry, 3y. Sorry, 3y. So all such that the frequency is always x by y. Understand? So what happens is that I wrote it wrong here. It will be increase. So I can say that when velocity will increase, lambda has to also increase. Okay. Now y is frequency constant. Let me explain it to you in a very innovative, like, so that you people understand. Let's say there's a box like this. Okay. Now let me redraw this. Okay. Let's say there's this box. 1 second. I draw like this. Okay, now from this box, let's say you have a hole on the top. My pen has just come open. Trying to fix it. Wait, I'll just pause the video now. Sorry, my pen had come open. So if you can see here, let's say this is one container I have, and I start filling it with water. So let's say it will obviously start filling. Now if I say I put 5 liters per second through this hole. Now let's say the water is still this level. Does my rate at which I am inputting water, 5 liters per second, change? No. So let's say when it is entering a medium, in the same example I'll use for light. If there is a medium, now light is entering the medium. Through this point, the number of light rays that pass per second, light rays per second, is what? Isn't that my frequency? That becomes my frequency. In the same concept, that is why the frequency of this location does not change. Understand? It will always be same. Understand? When it is changing medium, it will not change. That's why. Understand? This is why the frequency remains constant. Now we'll do some terminologies related to refraction. Okay, so I have drawn a diagram there. Let me show you. Okay, this is the diagram. This is what refraction is. So this part is called the medium 1. One second, medium 1. This is, let's say, medium 2. Okay, medium 1 and medium 2. This layer inside is, this is called interface. Okay, this ray that is entering is called incident ray. Let me rewrite this ray word, incident ray, that is going out. Remember, incident ray, reflected ray. This is now called refracted ray. Excuse my bad handwriting for today. This angle, you can see, this is, let's say, I. This thing is called R. Not writing this angle is called the angle of incidence. This angle is called the angle of refraction. Understand? This thing is called interface, I told, and this 90-degree thing, okay, this is nothing but my normal. Understand? These are some terminologies related to this. Let's say incident ray enters at an angle of 30 degrees, like this questions are framed. Okay, so now I think I will end it here, and I will first do a question before ending. This is the question. A student claimed that because of atmospheric refraction, no need to see the discussion. That's a previous question from this book. The sun can be seen after it has set, and the day therefore is longer than it would be if Earth had no atmosphere. First, what does she mean by saying that the sun can be seen after it has set? Second, comment on the validity of the conclusion. So for this is one application of refraction. Okay, let's say this is Earth. I can't draw now. Yes, I can draw. Let's say this is Earth. This is Earth, for example, and it will have an atmosphere above it. Let's say this is the atmosphere. Okay, let's say this is the atmosphere. So obviously the sun will set. You've seen a beautiful sunset or a sunrise, and let's say you are at this point. Okay, you've seen a beautiful sunrise, sunset, like that. Okay, so the sun will be something, let's say I think I have drawn the diagram too big. I have to redraw this. One second. Delete. I'll redraw the diagram little bit smaller. Let's say this is Earth, this is the atmosphere, and let me draw the Earth in a good way, and let's say this is where you are. Okay, well, atmosphere is nothing but a, I know atmosphere, what happens is that atmosphere is nothing but a glass for us. So atmosphere, if this is space here and this is the atmosphere, this is rarer and this is denser, so it will move towards the normal. Okay, we'll move towards the normal. Let's say the sun's positions first is here, then is here. Okay, now if you see, if I draw the light, let's say the yellow color, no, not yellow, red color, here it will enter, it will move towards you, it will bend. Okay, here also it will bend, and if you see in this place, it will bend towards you. My diagram is not, but actually if you see from this level, this is your level, so the sun has already set, but you can still see the sun because of this refraction. Actually, as a fact, you can also learn, you can see the sun, if this is the earth, here you can see the sun when when even the sun is actually 18 degrees below you. Okay, till that you can see that sun. That's what we call, like, when if you see, this thing is called the twilight. Okay, like the dawn dusk kind of thing. Okay, so I think I will end it here today.